Hello. So in this video, in the next series of videos, we're going to be looking at the chapter 10 in our class, which is on Markov chains. So when we look at a Markov chain, we're looking at a process where the outcome of an experiment depends only on the outcome of a previous experiment. Okay? So, for example, in sociology classes, a lot of times you'll see people being classified by income. So, lower class, middle class, upper class. And sociologists have found that the strongest determinant of income class of an individual is the income class of an individual's parents. So, here, what we've done is we've given you a table where we look at the current generation and each group, which in this case we're going to call each group a state. We're going to look at the next generation or each state, and we're going to look at the probability of achieving that state based on the current state. So, for example, if you are a low income person in state one, the probability of you staying in that same state would be 0.65 if you were to have a child and stay in that same state. The probability of a low income parent having a middle class income child is 0.28. And the probability of a low income or a low class income person having a upper class child is 0.07. So this is our table. So one of the things that we can do with this table is based on this, we can create what's called a transition diagram. So a transition diagram essentially is a way for us to look at each individual state and look at how we transition from one state to the next. So usually in a transition diagram, you'll have circles. So because we have three states, we're going to have three circles. So we have circle 1, we have circle 2, and we have circle 3. Okay? So based on the information we were given, the probability of staying in state 1 for the next generation is 0.65. So to express that, what we will do is we will just sketch an arrow like this and write the probability on the outside being 0.65. Now, according to our diagram, to transition from state 1 to state 2, that's a 0.28 probability. So we would do something like this, and we would sketch in 0.28. And we would do that for the rest of the diagram. So again, to go from state 1 to state 3, it's 0.07, so we would sketch an arrow like this, and we would go 0.07. And then we would repeat the process for the other two. So to go from state 2 and stay within state 2, 0.15. No, sorry, 0.67, not 0.15. Read it wrong. Because again, it comes from this entry. To go from 2 to 1, it's a 0.15 probability. And to go from 2 to 3, it's a 0.18 probability. And then we would do the same thing for 3. So to go from 3 to 3, it's a 0.52 probability. To go from 1 or from 3 to 1, it's a 0.12 probability. And to go from 3 to 2, it's a 0.36 probability. So this is an example of what our transition diagram would look like. Now, the only downfall about the transition diagram is it can be a little confusing to read, especially with all the different arrows. So another way that we can express this information is in what is known as a transition matrix. So with the transition matrix, we label it as P. So I'm going to basically take what I did up here in this table and I'm going to create a matrix. So we have 0.65, 0.28, and 0.07. That's in row 1. 0.15, 0.67, and 0.18. That's in row 2. And then 0.12, 0.36, and 0.52, and that's in row 3. So this is what our transition matrix would look like. Now, 3 ideas that come about from this transition matrix. One is that it's a square matrix. So remember, a square matrix is where all the rows and all the columns are the same number. 2, all entries are between 0 and 1. Again, it goes back to the idea of probability. All probabilities are between 0 and 1. And then last but not least, the sum of each row is equal to 1. So just to recap, for transition matrix, 3 things that do pop up. It's a square matrix. All the entries are between 0 and 1. And the sum of each row is equal to 1. So if we look at this idea of a Markov chain, we can say that the sequence of trials of an experiment is a Markov chain if the 3 following things happen. 1, the outcome of each experiment is one of a set of discrete states. So the discrete states mean that they're individual. So in this case, in the previous example, you were either lower, middle, or upper class. So each one of those is a discrete, distinguished state. 2, the outcome of an experiment depends only on the present state and not on any of the past states. And then 3, the transition probabilities remain constant from one transition to the next. So that means they do not change whatsoever. All right, great. So I'm going to go ahead and stop here with this part of the video because I know some of you had mentioned that you don't like the longer videos. You'd like me to chunk it up in the shorter sections. So in the next video, we're going to be looking at finding probabilities as we go through transitions. So as always, if you have any questions, feel free to send me an email, ask the questions in the email, or ask me to set up a Google Meet. Otherwise, until then, we'll talk to you later.